Hello students, greetings for the day. In this video lecture, we are going to study about the data memory management of PIC 18F458 family. Okay, so as we are going to discuss about the memory, just let me make few things clear. See, human body do have a memory, right? So usually what do we say? Our brain stores everything. Okay, do the humans have a hard disk or a chip to store all these things? No. So where the data is stored as far as the human being is concerned? But we remember everything. Some of the things we do forget, right? But human beings brain or the storage is in the form of neurons. We learn from neurons. Data is stored in the form of neurons. Okay, so either it may be a temporary data or a permanent data. Okay, so see, human brain deletes automatically some of the things. Okay, so we can call them as a temporary data, and the one which you can recall forever is called as a permanent data. Okay, so just let me give you an example for this. Suppose 1 month back, from a stack of your dress, which dress did you put or wear? We may not really recall it, like which dress exactly did you wear 1 month ago and on this day and at this time. So this is a temporary memory, just you wore that dress and it's finished. Now again I may not recall like when did we wear that dress again. Same is the condition, like what food did you eat 8 days back? No, it's highly impossible. In some of the cases it may be possible, but probably it is not possible to memorize or to remember or to recall all these things. But if I say that in which school did you study? Do you remember the name of your school? Do you remember the name of your teachers? Do you remember the name of your friends? Do you remember the name of the class toppers? Do you remember the name of your teacher who used to scold you for not doing your homeworks? You may remember, because this is a permanent data. This is a permanent data. You cannot forget your childhood. You cannot forget your teachers, your friends, your school name. Okay, because these are the permanent things. These are going to have a great impact on you. You have spent most of your time over there. Same is the case with the memories in case of processors or the controllers. Okay, so this was just an example, like it may either be a temporary memory or it may be a permanent memory as well. Okay, so just let me make it clear about the data memory organization. This is very important part as far as the PIC 18 family is concerned. Okay, so the data memory is basically implemented as a static RAM. Each register in the data memory has a 12-bit address. As it is 12-bit, it's going to allow us up to 4096 bytes, that is 4 KB of data memory. So the data memory available with 18F family is 4 KB. Okay, because it's a 12-bit address. So we are going to see the figure for it. Okay, so the data memory map is basically divided into the 16 banks, and each bank is gonna consist of 256 bytes each, where the lower 4 bits of BSR, that is a bank select registers, will be kept for selecting a bank, and the upper 4 bits of BSR will not be implemented. The data memory contains special function registers and the general purpose registers. The special function registers are used to control and status of controller and the peripheral functions, while general purpose registers are used for data storage and scratchpad operations in the user's applications. The SFR starts at the last location of bank 15. Bank 15 do have an address 0xFFFH and grows downwards, whereas GPR start at the first location. It means it is bank 0. Okay, so this thing is to be kept in mind. No doubt we are going to see it in the diagram as well. Okay, So this is just the description about the whole memory management, whatever we are going to see. So I'll just cover it in that, instead of reading it I'll just cover it there itself. Okay, but notice here general purpose register and special function register. So the register file can be accessed either directly or indirectly. Okay, indirect addressing operates through the file select register, whereas the data RAM is available for the use of GPR registers by all instructions. Bank number 15 contains SFR. All other banks of data memory contain GPR. Okay, starting with bank 0. And special function registers. The special function registers are the registers which are used by the CPU and the peripheral modules for controlling the desired operation of the device. These registers are implemented as the static RAMs. Okay, so see here it will be very clear now. Now see, the data memory is divided into 16 banks. I think it's noticeable. Okay, so I'll just highlight them. Bank 0, 1, 2, 3, 4 and up to 15. It means there are 16 banks. I'll just write the number over here. These are 16 banks. Okay, each bank consists of how much bytes? 256 bytes. Each bank consists of 256 bytes, whereas the lower 4 bits of BSR selects which bank will be accessed. Okay, the bank select register is a 12 bit. Okay, so as it is a 12 bit register, 8 bits are used for RAM addresses and the 4 bits are used for bank select register. Okay, so the data memory consists of special function register and GPR, that is general purpose registers. You can see here the special function registers and the general purpose registers, where the special function registers are used to control the status of microcontroller and the peripheral. You can see this SFR, these are placed at bank number 15, and what is the function of this special function register is to control the status of the peripherals which are connected to the microcontroller. Peripherals are nothing but the external devices which can be connected to the microcontroller, whereas the general purpose registers are used for data storage. Okay, so you can see here general purpose registers start at bank number 0. Okay, start at bank number 0 and it is then growing downward. See, you can see it is growing downward. Okay, so it started with bank 0 and it has now grown downward, occupying the entire memory so that it can be accessed, either directly or indirectly. So whenever you want to access the memory directly, you require a bank select register, and wherever you want to access the memory indirectly, you would require a special FSR, that is a file select register. You will be requiring a file select register. So these important points to be noted. So each location holds 1 byte of data. See here, this is one location, one location, one location. Each of the location is going to hold a 1 byte of data. 1 byte of data means only 8 bits can be held, not other than that. Okay, so first instruction will require one word. One word means 8 bits of location. Okay, one word means 16 bits, so it will require 2 location. Okay, so instructions and the architecture are in such a way that each of the bank can be accessed. So see, we can access each of the bank. Okay, so for that you also have a access bank. So what is this access bank? It is nothing but a combination, or it is just the splitted portion of your data memory. This data memory is splitted and it forms a access bank, but it is a combination of GPR and SFR. As it is SFR, obviously it is going to be a bank number 15, and as it is a GPR, it means it will be bank number 0. So I can say that access bank is a combination of bank 0 as well as the bank 15. If you see the addresses, these are also of the respective bank only. this is the address of bank 0 and this is the address of bank 15. Okay, so in order to do this, you have the access bit called as A. It is small a. If A is 0 and A is 1, so when A is 1, the BSR is used to specify the RAM location. So when this bit A is equal to 1, you have to use a BSR, that is this side, okay, to specify the RAM address. Lekin if the A bit is 0, you have to utilize the access bank itself. Okay, so access bank, it can either be the high bit or the low bits. Okay, so basically what data memory is doing, data memory is trying to divide the banks. So there are 16 banks, so we can use to configure it. So in this way, the bank are being divided. Okay, so this is in short a data memory map of PIC18F family. Whereas here also you can see, okay, in binary the bank select registers are written. If it is bank 0, it means the entry should be 0000. If it is bank number 5, it should be, see here, it is 0101. Accordingly it is being selected. I would just give you some important highlights about the 18F458 family. It's a 40 pin DIP package. DIP stands for dual inline package. It is having 8 channels and 10-bit ADC. It has 2 comparators. It has a CCP module. It's 1N number. CCP module stands for capture, compare and the PWM, that is pulse width modulation. It do have a advanced CCP module, that is ACCP module. It is also 1N number. It has one USART, universal synchronous asynchronous receiver transmitter. It has 4 number of timers in which the division of timers is being done. There are 3 timers which are of 16 bits and there is 1 timer which is of 8 bit. So this is all about the data memory management. I'll just conclude this. So data memory is basically of 4 KB. Why? Because it has 12 bits. So 2 raised to 12 is 4096. It means it is of 4 KB. This 4 KB memory is splitted into 16 banks, which are then divided as general purpose and special functions. General purpose are the ones where your data will be stored and it grows downward or in a downward direction, whereas SFRs are nothing but used to see the statuses or doing the controlling action as far as the peripherals devices are concerned. Then if you want to see the splitted form of your data memory, you can split it and see the access bank, where it is a combination of bank 0, which is a general purpose register, and a bank number 15, which is a special function register. But you should have a access bit A, okay, so that you can know whether the RAM address to be selected is from a bank select register or a access bank. So when A is 1, obviously you should select a BSR, that is a bank select register, and when A is equal to 0, you have to select access bank. Thank you.